Okay, we dive headfirst into analyzing the data. In Kaggle, when you click in a notebook, it is as many other cloud-based services such as Google's Colab or Microsoft's Azure are like all kinds of cloud-based computation environment. It will create a remote virtual machine for you. It is like you are dealing with your private machine, but it's running on cloud and it's a virtual one. What is particularly convenient for this particular task is that on this virtual machine, a copy of that dataset has already been put in one virtual local folder for you, so you will have access to the data directly. The data will be put in the, I will click edit, so that will start the virtual machine, and I will have a live session to interact with the machine. So you can have a look at your virtual CPU, virtual memory, and virtual hard disk. Also, you can have other resources. Maybe you can pay some money to get more powerful computation resources. So, but for this task, we are very happy with the freely provided resources. And you can see the data set has already been put into a folder, which is from the root folder, Kaggle, subfolder, and input. Well, this has already been set up by default, either by Kaggle setting up or by the author of the dataset. So I will just use the code provided by the author and load the data. So this, we introduce some necessary libraries, which of course by Kaggle ask us, you need these libraries, just import those libraries. And so I will introduce you that your data is in this folder, so have a look. Oh, that is embarrassing. Where is our OS? Give it. Oh, that is a kind of weird behavior of Kaggle. I select this portion of the data and I click run, it runs this portion because we haven't tell the virtual machine that we will use this library. So when we try to use this library in this selected part, it complains. So now it works. It shows that there are two files in the within the folder. One is the U.S. presidency election, and another is a primary result. Of course, it is 2016, and also in the dataset it contains information of earlier elections. We will see that in a moment. Now we know those files are of interest. We just use the data load function provided by the author and load the data into this data frame. Data frame is a table that contains the contents of the data. You can consider that is as an Excel spreadsheet. I even would not like to see it's a virtual one. It's a real one. Just you cannot visualize that. You can visualize that, but it's not so direct. Okay, let's go with this. So let us have some very primary investigation. I would say let's see how many records in the data, which means how many rows in the table. Look at this little bit funny printing statement. That means I will print this information. Look, but within this curly bracket, please do not print the content in the curly bracket literally. Treat the content between the curly bracket as a Python code and execute the code where in this case I extract the number of records of the data set, which is the rows. So basically, it reports you have this many records. Okay, and then we have a look at the first few records, first 5. So you can see we have 3,000 something, which correspond to the individual counties of United States. I will enlarge the font size a little bit to make it more readable. And it also contains some placeholders for the entire state. Okay. No, is it a placeholder or not? I don't know. But we will discard the places where the data is missing anyway. Okay. So, but this contains more columns than which can be conveniently comprehended. Therefore, I would like to print out the keys. By keys, I mean those aspects or data attributes or different kind of information per county, per place we can have a look at. So then we will have a look at, okay, for each place it will have this many information, such as in which state it is in, the county in, such as like this Duval County is in Florida. Of course, this information is a replication of this one, but it is convenient reference of the state. And the abbreviation, maybe some geographical coding, and all the statistics such as how many votes it has, and how many votes Democrats received in 2008, and how many votes Democrats received in 2012, and also I think maybe the votes in 2016 is more recorded with more details, such as how many votes Donald Trump and Hillary Clinton and other candidates received in 2016. So also it has some summarized results. I think those numbers are in proportions. I know this because I have already got a small overlook, a glance of the data. You can do that by yourself, which is pretty straightforward. Say for this part, one more bit before we get into okay, why not? We can just have a look at the data. Let's call that USA 2016 election. So we do this, and maybe have a look at say Republicans 2016. So okay, these are our records, and it looks like percentages. You can have more than one attributes to look in the same time, in which it will give you a table. So let's also include the county name, so we know the Republicans perform how well at different places. Okay, I delete this one. Before we proceed, let's drop the non-existing record from at least from those columns that we are interested in, because look, if I'm interested in how many votes Hillary Clinton received in 2016 and Republicans' performance in the past several years, so on and so forth, I will drop non-available values from those subset of attributes. That means whenever a row contains missing values in these columns, this record will be dropped. So we keep some more or less valid data to look at for the next.